All right, today we're going to be finding inverses of exponential and log functions, and it's going to involve solving exponential and log functions, just like we've been doing the last couple lessons. It's also going to take your knowledge about inverses from earlier this year, which might be a little bit rusty. It's been a while since we've done it. And so I think it should go quite well. Let's start by making sure your initial knowledges of inverse functions is pretty good. So let's look. So I am not going to count these as points, but you will get to skip an explanation, and you should try to do them by yourself if you can. So this first one, find the inverse of the function below. I hope we remember that to find the inverse function, what we're doing is we're switching x and y. What an inverse function does is it undoes the original function. It's all the operations that would be necessary to undo the original function to make the inputs and the outputs switch. So when you have an equation, what we do is we start by switching, the y becomes x. Everything else stays the same. The 2 and the 4 stay here, but instead of 2 multiplying times x, it's going to be 2 multiplying times 4. Nothing else changes. Plus is still plus. Everything's the same. The y became an x, and the x became a y. And from here, we always solve for y. Solve for y. So we're going to find what y is. And to do this, we have to do the inverse operations, which is what's going to find us our inverse function. We subtract 4. And so we get x minus 4 equals 2y. And lastly, we divide by 2. Sometimes the dividing by 2 will distribute across the binomial. X minus 4 is separated by a minus, so it's a binomial. And the dividing by 4 will distribute. X divided by 2 we usually write as 1/2 x. And 4 divided by 2 we usually put as 2. And this is equal to y. Sometimes we'll rewrite it with the y first. Y equals 1/2 x minus 2. Okay, so this is the inverse function. If you put any input in for x, like let's say we put x equals 3 in, 2 times 3 is 6, 6 plus 4 is 10, and so when x is 3, y is 10. In the inverse function, oh, you guys can see that? In the inverse function, when we put in 10, we should get out 3, and we can check that. When we put in 10, half of 10 is 5, and 5 minus 2 is 3. So in the original function, when we put in 3, we get out 10. In the inverse function, when we put in 10, we get out 3. And that will be true for all x's and y's. They'll get switched. All right, why don't you guys try this one on your own and see where you're at. Hopefully you realize that this is just a fancy way of writing y. So when we switch it, we're going to say x equals square root of y minus 3 plus 5. And now that we switched x and y, we want to get x by itself. So x minus 5 equals square root of y minus 3. To undo the square root, we need to square both sides. We need to be a little careful here. This binomial can be squared. And I'm actually going to go ahead and square it because we know a squaring a binomial trick. We square the first one. We multiply these two together and double it. So x times negative 5 is negative 5x. Doubled is negative 10x. And then we square the negative 5, which is negative 5 times negative 5 is positive 25. You also could have squared it by doing x minus 5 times another x minus 5 and multiplying it out. But what you can't do is distribute the squaring. That's not a thing. You would be missing the negative 10x if you did that. And last, of course, we add 3 to both sides to get y by itself. Now this one's slightly different because, so we've got y by itself. It was written as f of x, so usually at the end we will write f inverse of x to say, hey look, this was the original function, this is the inverse of that original function, and it will equal x squared minus 10x, 25 plus 3 is plus 28. So there is our inverse function. And guys, this should make sense, right? The inverse of a linear function, remember that on a graph, it's reflected across the across the line y equals x. So what ends up happening is a linear function will reflect to a linear function. A square root function will reflect to a quadratic function. This ends up being like this, right? And an exponential function will reflect to a log function. Those are inverses of each other. I'm sorry about that, guys. I just bashed my camera. All right, why don't you try this last one? This is a new type of function we want to find the inverse of. This is an exponential function, but the steps are the same. See what you can do? Hopefully you switched x and y. And then to try to get y by itself, we see an exponential here. This is solving an exponential equation. We want to divide by 3 to get the exponential by itself. And we can leave it as x divided by 3, or a lot of times we'll put 1/3 x. And to undo an exponential, we do a log with that base. So this is an exponential with a base of 2. We do a log with a base of 2. That's it. So here, this will cancel out, and we'll get y equals, I'm going to put this on the side, log base 2 of 1/3 x. So we're just doing inverse operations we switch x and y, and then we solve for y by using inverse operations, and it finds the inverse function for us, which will undo the original function. Finally, let's make sure we have good base skills. What are four of the points that are on the graph of y equals 3 to the x? And hopefully we know that anything to the 0 is 1. So when x is 0, y is 1. 3 to the 0 is 1. When x is 1, y is 3. 3 to the 1 power is 3. So I'm going to put a point at 1, 3. When x is 2, y is 9, because 3 squared is 9, 2, 9. And let's do a -1. When x is -1, y is 1/3. So when x is -1, y is 1/3. And I hope we remember that all negative exponents will end up being lower and lower fractions, and so we end up with this asymptote here. This is the exponential function, y equals 3 to the x. And on the same graph, we want to graph y equals log base 3 of x. And so what are 4 of the points that are on log base 3 of x? And hopefully we remember that, these are inverses of each other, and we could just switch the x's and the y's, but we'll verify this in a second. 1/3, -1, 1, 0, 3, 1, 9, 2. And let's just check to see this works. When x is 9, log base 3 of 9 is 2. When x is 3, log base 3 of 3 is 1. And so these points are the inverse. These are the log points at 1, 0, 3, 1, 9, 2, and -1/3, -1. And I hope we remember about log graphs that the parent functions have an asymptote at x equals 0. Because when you put in fractions into logs, like when x is 1/27th, the y will be -3. So there's this asymptote we get close to there. So I hope we recognize that these are inverse functions. They are reflected across the line y equals x. But we can also get them by switching x and y and then doing inverse operations to solve. So we'll be practicing that some today. Let's start by doing some inverse functions and making sure we can feel comfortable doing them. So let's start with f of x equals, 5 to the x plus 1 minus 4, okay? We want to find the inverse, so find the inverse. So in our notes, we want to make sure we have how to do this setup. So step 1, we're always going to switch x and y. So here's our y, it's going to become x. Here's our x, it's going to become y. Everything else stays the same. And then 2, solve for y. This is no different than the directions were at the beginning of the year when we were finding inverses. We just have a different kind of function, exponential functions, which we know how to solve now. We get the exponential by itself. We've now isolated the exponential. Here's that exponential. Something to a power that has a variable in it. And now to undo the exponential, we need to do a log. So log base 5 of x plus 4. Make sure you do the log of the whole side. So here it's not just log base 5 of x plus 4. Make sure this has to go in parentheses. Because if you just wrote log base 5 of x plus 4, that makes it look like you're doing log base 5 just of x and then adding 4 to the end. Here the order is you add 4 and then do log base 5 of that answer, and that's the right way to do it. You have to do log base 5 of the whole side. Finally, I'm going to switch the y plus 1 to this side. Y plus 1 equals log base 5 of x plus 4. We usually put y's on the left. We're going to subtract 1 on both sides, and this needs to be outside of the log. So it is not inside of the log. Make sure you don't put it inside the log. At last, since it started with f of x, I'm going to write f inverse of x equals, this is the inverse function. Notice that the plus 4 needed to be inside of the function and the minus 1 needs to be outside of the function because of the order of operations that we did it in. We added 4 first, then we did the log base 5 of the whole side, and then we subtracted 1, but that's not inside of the log. So make sure you're being kind of careful about the order. Why don't you guys try one on your own? Try y equals 2 times 3 to the x minus 2 plus 6. And hopefully you started by switching x and y. So x equals 2 times 3 to the y minus 2 plus 6. And now we're just solving for y. We want to get the y by itself. The y is inside of an exponential function. So we need to get that exponential function by itself. So we're going to subtract 6, x minus 6. We're also going to, I guess I'll rewrite it. We're going to divide by 2 because the exponential, this exponential is getting multiplied by 2. So we'll divide by 2. When we have dividing across a binomial, we'll usually distribute it and make sure we do x divided by 2, which is 1/2 x. 6 divided by 2, which is 3, especially if the 2 divides into one of them evenly, that'll make us more likely to do that, although we don't have to. Okay, now here's our new step from this unit, which is that if we have an exponential, to undo an exponential, we need to do a log with that base. So log base 3. And so log base 3 of 1/2 x minus 3. Notice that it's in parentheses. And finally, we need to add 2 to both sides. And that 2 does not combine with the minus 3 because the minus 3 is inside the log. We're going to do log base 3 of all of this. And then after we've done that, we'll add 2. And that's what y is equal to. Great. That is it. Yeah, the 2 and the minus 3 do not combine. All right, let's do a log one. Let's do a log one. Let's do y equals log base 2 of x plus 4 minus 7. And I think this should go just super smoothly, but let's do it together. Let's make sure we're good. What should be our first step here? And hopefully we all know we switch the x and the y's, right? We're gonna switch the x and the y's because we're finding the inverse. So to find the inverse, I guess I should have said that, find the inverse. We are gonna switch x and y's, and then what should our next step be? Well, we're gonna add 7 here to get the log by itself. So x plus 7 equals log base 2 of y plus 4. To undo a log, we need to do 2 to the power of both sides. And this is 2 to the power of the whole side. Be careful here. So 2 to the log base 2 needs to be 2 to the power of x plus 7. So 2 to the x plus 7 power. Not 2 to the x and 2 to the 7th. 2 to the x plus 7 power equals y plus 4. And last, we need to subtract 4. And this minus 4 does not combine inside the exponential. We write it as 2 to the x plus 7 power minus 4. If we put the minus 4 up there, it would be saying we'd be doing it as an exponent, which isn't what we're doing here. So this is what y is equal to. Y is equal to 2 to the x plus 7 minus 4. These are inverse functions. And again, if I were to put in, a point, like let's say I put in x is 0 to the beginning. When x is 0, what is y equal to in this function? Well, when x is 0, 0 plus 4 is 4. Log base 2 of 4 is 2. 2 minus 7 is negative 5. And so when we plug in 0, we get out negative 5. And that means that in this function, when I put in negative 5, I should get out 0. Let's check. Negative 5 plus 7 minus 4. We'll put in negative 5 for x. And negative 5 plus 7 is 2. And 2 squared is 4. 4 minus 4 is 0. So when we put in negative 5 for x, we get out 0 for y. Notice that the x's and y's were switched. All right, guys. I'm gonna give you a couple to practice just to see if you're on the right track. Let's try something funny. Let's see, can you tell, is this an inverse or not? So let's do this. We'll say f of x equals 3 to the x squared minus 7. Is that, it is a tricky one, is that an inverse function of g of x equals, oh man, sorry guys. log base 3 of square root of x plus 7. Are these inverses or not? Are f of x and g of x inverses? And the way to do it is just to take one of them, find the inverse, and see if it gives you the other one. So find the inverse of f of x. Is it g of x or not? And hopefully you started by switching x and y. So this is the y, it becomes x. This is the x, it becomes y. And because the x squared minus 7 is in the exponent, this whole exponential is already isolated. So we're going to do log base 3 on both sides. And so we get log base 3 of x equals, this cancels out, y squared minus 7. And we're going to add 7 to both sides. So log base 3. Now this is important. When we add the 7 to the other side, we're going to make sure we close the parentheses to show that the log ended. We already did log, we're not doing log base 3 of 7, we're just adding the 7 to the other side. So we want to close the parentheses here to show that the log ended, and now we're just adding 7. And last, we'll do the square root. So y equals the square root of, we're going to do the square root on both sides, log base 3 of x plus 7. And so f inverse of x is equal to square root of log base 3 of x plus 7, and I really should have a parentheses here to show that the plus 7 isn't inside the log. Now, this has all the same operations, but it's in a different order. These are not inverses. Even though they have the same operations, they won't do it. Another way we could have done it is we could have plugged in a point here and seen what we got out, and then tried to plug in, like switch the points and see if we got the right points out. Because remember, anytime we plug in an x, like let's say we plugged in 3 here, we'll get out 3 squared is 9, 9 minus 7 is 2, 3 squared is 9. So when we plug in 9 here, we should get out 3, and we won't. When we plug in 9, we get square root of 9 plus 7 is 16, square root of 16 is 4. We get log base 3 of 4, which is not 3. So they're not inverses. The last thing we're going to do today is we are going to graph 2 inverse functions. This is going to be a pretty short lesson. We are going to, so go ahead and start by graphing y equals 3 to the x plus 4 power. Okay. Hopefully we feel good that this is an exponential function, and you should know the parent function, and we can shift it 4 to the left. So what we're going to do is we know there's a point, the parent function, the parent is y equals 3 to the x, and you should know that on that parent function, there's a point at 0, 1, 1, 3, 2, 9, negative 1, 1/3, whatever. And this is going to be a shift left by 4. So I like to start with that point at 0, 1 and shift it left by 4. Take this point, shift it left by 4. Take this point, shift it 1, 2, 3, 4 left. Take this point, shift it 1, 2, 3, 4 left. I think this is the fastest way to graph it. And now we can see that there's still an asymptote at y equals 0, because the asymptote, which is at y equals 0, also shifts left by 4, so it doesn't change the asymptote. And so this is the new function. And we could do the domain and range. What's the domain for this? What is the domain for this guy? The domain is all the x values, and we can see it going to the left and to the right forever. So it's real numbers, or from negative infinity to infinity, right? There's a few different ways to write it. The range is what? What's the range of this function? What are all the possible y's? Well, we can see that the y's won't go below 0. All the y's are above 0. So the y's are all above 0, or we could write 0 to infinity. Those are both fine. This function is increasing and concave up. It's both increasing and bending up, so that's nice to know. Good. Let's see. Find the inverse of y. Find the inverse function here. Go ahead and do that on your own. And hopefully we can see already we need to switch x and y. And the exponential is already isolated here. So we're just going to do log base 3 on both sides. And so we've got log base 3 of x equals y plus 4. We're going to subtract 4 on both sides. Be a little careful here to make sure you close the log to make it clear that the minus 4 isn't inside. And here's our function, y equals log base 3 of x minus 4. Go ahead and graph this. Hopefully you feel good that the parent function of logs have a point at 1, 0, because let's graph the parent function. So y equals log base 3 of x before it gets subtracted by 4. So it'll have a point at 1, 0. We always also go to the base of the log, and that'll be 1. So log base 3 of 3 is 1. So we go to when x is 3, y will be 1. And then it has an asymptote at x equals 0. And we said that this is good enough for us, right? We could get more points. Like we could get 9, 2 would be a point, and we can get an even better graph. But what's happening is this graph is getting shifted down by 4. I like to start with the asymptote. The asymptote was at x equals 0 when you shift down by 4. It'll still be at x equals 0. So there's still an asymptote at x equals 0. This point at 1, 0 will get shifted down by 4. 1, 2, 3, 4. This point at 3, 1 will get shifted down by 4. 1, 2, 3, 4. And we can still follow that asymptote. And there's a nice graph. It'll look like this. And, at the end, we can check and see, is it reflected across the line y equals x? And it sure looks like it is, right? This point at 3, comma, negative 3. The other point on this one should be negative 3, comma, 3, and it is. This point is negative 3, 3. So notice that the x's and the y's are all switched. It's reflected across the line, y equals x. All right, guys, you'll get some good practice on all this stuff in your homework, but I think that's enough for this video lesson in terms of, what we needed to get done. Have a good rest of your day. Bye.